Okay, in this video we're going to look at the derivation of the wave equation through use of, by way of Maxwell's equations. This can be done for both the electric field and for the magnetic field. We'll also be using heavily this vector identity. To start with, this method heavily uses substitution, which we all learn in algebra. First, we're going to be dealing with a situation without current, without charge. So both of these are going to be eliminated. Next, I'm going to take this equation and give it the first time derivative. First time derivative, curl of B equals U naught epsilon naught E. However, since multiplication is commutative, I can swap these two around. So I have the curl of the time derivative of B. However, time derivative of B is the same thing as this. So we can substitute it right in. Now we have the curl of negative curl E. Pull the negative out here. Now we have the curl of a curl, which we learned about right here. Curl of a curl is, let's have a bit more room. Curl of a curl is the divergence of the gradient. The gradient of a electric field, which we decided was, in this case, is going to be 0, minus the Laplacian of the electric field. Well, this is going to equal, looks like I lost a minus sign, didn't I? When I did this, I should have a minus sign, so it can become positive. Okay. Equals U naught epsilon naught second time derivative of E. Well, that's gone, so what we're left with is 1 over U naught epsilon naught squared. Sorry. U naught epsilon naught Laplacian E equals time derivative squared E. And that right there is the wave equation. Now, you remember the wave equation as being V squared Laplacian E equals times derivative squared E. Well, in this case, this 1 over mu epsilon is the velocity of light squared. So we can conclude the speed of light is 1 divided by the square root mu naught epsilon naught. Now, likewise, we can turn around and do this for the magnetic field using the exact same procedure, which I will just briefly outline. Instead of starting with this equation, taking the time derivative, we'll start with this one and substitute this into here. We'll get the same formula.